All right, so we just got done looking at walking through an example of, let me show you where we just were here, sorry. We were looking at this article in Critical Care that was a nice review of logistic regression, and so please make sure that you read over that article. So with odds ratios that we were talking about earlier, here's some example from another study. That looked at complications in patients undergoing hip fracture repair, comparing the effectiveness of regional versus general anesthesia. And so they used some logistic regression modeling in this particular study. And these were some odds ratios that they presented in their study. And so what I want to point out to here is that one is these two are both significant. And we can tell that they're significant even if we didn't have the p-values, because they don't include 1 in the confidence interval, whereas this one does. It crosses over 1. But what this is showing is, so the odds of death after hip fracture were reduced by approximately 29% when regional anesthesia was used compared to general anesthesia for hip fracture surgery. Likewise, pulmonary complications were decreased by approximately 25%. So with odds ratios and relative risk ratios, we can also calculate how much difference it is, the magnitude. So if it's less than 1, you take 1 minus this number. If you subtract, and that gives you that percentage difference in decreased odds, or if this was 1.7, then we'd say there's a 70% increase in the odds of death. Here's another study that I've included, and it's part of your readings this week. It's part of the discussion question, and it's also going to be your first one of your article review assignments. And this was a particular study that some of you may have read at some point. It was published back in 2009 that looked at predictors and outcomes of impossible mass ventilation, and they reviewed about 50,000 anesthetics. And what they identified was that overall they found about a rate of 1 in 690 impossible mass ventilations in this particular, and this is from a large academic medical center, 25% of which were difficult intubations. And they had about a 1 in 2,800 risk of what's called impossible mass ventilation and those who could not be intubated, or difficult intubation. So that's your worst case scenario. But what I wanted to point out to you here was that they could, using that ROC curves, but what they were able to do was come up with different cut scores with 1 risk factor, 2 risk factors, 3 or more, or 4 or more risk factors. And so what this came up with is that they came up with an odds ratio of, if they had 3 or more risk factors, they were 8.9 times more likely to be impossible mass ventilation if they had 3 or more of these particular risk factors. And you can see each one of these had a different odds ratio associated with it, with neck radiation changes having the greatest risk. So this is just an example of how logistic regression can really help us inform our screening and management of patients. The other thing I want to point out to you here is that we have here that if you're like, oh man, if somebody has 4 or more risk factors, they're 25.9 times higher odds of having an impossible mass ventilation. Now, the one caveat to that is it's not a very precise measure because the confidence interval is not very good. It ranges from 11 to 60, whereas probably the most precise measure here is this 2 or more risk factors. Now, some of you, hopefully you all are familiar with the Apple's risk factors for postoperative nausea and vomiting. So when they developed these consensus guidelines, they used logistic regression to identify them. And I've included this article for you guys to take a look at that you can read through this week to get a little bit better understanding of how they came about this. Okay, but if you read the consensus guidelines, this is what they came up with. And the real question is, how did they get to this point of coming up with these single point scores, and then coming up with the risks? So this original study, this was actually the consensus guidelines that were the most recent ones on nausea and vomiting. Actually, one of the original studies was here by Christian Apfel back in 1999, where he entitled "A Simplified Risk Score for Predicting Postoperative Nausea and Vomiting." And he had data that he combined from two different centers to cross-validate his model for identifying risk factors. And so you could pause the video, you can certainly read through that, and I've included the article as a reference for you guys. But here's kind of the nuts and bolts of what they came up with, is that they came up with this. Here's your standard regression output, where they came up with the beta coefficients, and then they calculated the odds ratios for those. Now, the way you take this beta regression and you convert that to an odds ratio is that you take the exponent of that regression coefficient. So in this case, they took the exponent of 1.268 equals 3.55. So if you actually go into Excel and you type equal exp, and then you put this number in the box, you'll be able to come up with that. Okay, so actually let me just show you how you can do that function in, actually I can't show you right now because it'll screw up our video, but you could type that function in Excel and it calculates that odds ratio for you. So if you read an article and it didn't give you the odds ratio, you could use the beta coefficients to calculate the odds ratio. To convert it back, you just do the logarithm of that odds ratio, and that gives you the 1.268. But what they did is they developed simplified scores were developed by, what they did is they equally weighted each one of these risk factors, even though they don't appear to always be equal. And they did some kind of complicated statistics in there, and I'd encourage you to kind of read over it. You don't need to memorize it, but just kind of get a handle, a sense of what they may have tried to do. But what they did was they developed these multiple ROC curves were plotted using the simplified score, and then they compared the different what they call the area under the curve, and they really didn't see that much difference between, when they just went to using a single score of 1 as opposed to the actual odds ratios. And so then what they did is they came up with simplified scores were then entered. And they did a second logistic regression on the original data set, so that for each of the risk group, they could calculate an expected incidence of PONV using a simplified scoring strategy. So one of the things they wanted to do, they wanted to make this easy for clinicians to calculate. Even though we probably know that some patients, that female gender, according to this, shows that they probably have the highest odds of PONV compared to maybe motion sickness with an odds ratio of 1.91. But to make this a little bit easier, they came up with this ability to go with just a single score of 1. But what they did here is they kind of had this decision criterion where they use these different cutoffs. And then this is the overall AUC with all 4 of these. So this is if they had 0 risk factors, 1 risk factor, 2 risk factors, 3 risk factors, and 4 risk factors coming at, they're about if they have four of these risk factors, they had about an 80% risk of postoperative nausea and vomiting. And overall, this model had a good classification of about 0.75. So 75% of the time, they got it right. Okay. And this is what I mentioned just a few minutes ago is when they calculate a logistic regression, it's an estimated increase in the log odds of an outcome per unit increase in the value of the exposure. And this is where they have that. They take essentially you're taking the exponential function of the regression coefficient and calculating the odds ratio. And so that's what you can essentially, you could do this in Microsoft Excel, and you could actually calculate the odds ratios, and then you can go back and reverse it. And so some of the things that you will see, you may read in the papers, manuscripts with ROC curves, is they talk about what is a C statistic. It's sometimes called the concordance statistic or the C index. And it's a measure of goodness of fit of that logistic regression model. And it gives a probability of randomly selected patients who experienced an event had a higher score than a patient who had not experienced it. And so it has this. So essentially, what they show you here is a model has 0.5 as a poor model, meaning it's not any better than random chance. 70, what they're 0.7 indicates a good model. And so if we go back to this example, they came up with an AUC. You can call that your C statistic of 0.75. So that's good, according to this table here. 0.8 would be very strong, and 1 would be perfect, which would almost look like something like that. Okay. So I hope that this crash course on logistic regression was helpful for you. Please watch the videos that I had posted at the beginning of the slide deck. That's going to help give you a little bit better understanding of logistic regression. It may help explain some concepts that you may not that I may not have done as good a job of explaining for you. And certainly, if you have any questions, feel free to contact me. And also please take a look at the articles that we have posted for you that were referenced in this lecture. Thank you.